Hello and welcome back to this latest video in the series of videos that we're making for the group. In this video we're going to be looking at some software, how to write some very simple software to basically just make LEDs flash on and off. We're going to be compiling the software and sending it into an Arduino development board. We're going to be using an Arduino board. This is the board here with the ATmega328P microcontroller chip on the board here, and we've got a USB cable which goes to the PC, and we've got a little bit of a proto board here connected in with some jumper wires. Got a couple of little green LEDs here and a little tactile switch here, and we're going to be using these later when we come to the results of the software compilation. So okay, that's basically what we're dealing with. Arduino board here with the chip, some jumper wires, a couple of components and stuff on the proto board, all very simple, and I'll show you the circuit diagram for that now, the way we've actually got this wired up. Okay, so here we are with the circuit diagram. Here's our Arduino development board here, and you'll notice we've got some pin numbers here. These are the pin numbers that's actually written on the board, not to be confused with the numbers that's on the chip itself. These are silk screen on the actual board. We've got a couple of LEDs here. One of the LEDs I've called LED int. That's for the interrupt status. We'll be coming to this later. I'm not going to use that straight away. LED flash is basically going to be our flasher LED, which we're going to set to 1 second to flash on and off. And this is just a basic introduction video just to get us started, in case you've never seen the Arduino IDE before. If you've never programmed microcontrollers before, then you may find this useful just as a bit of a startup video. Okay, so we've got two LEDs. These comes from pins 12, pins 13 from the board, and they go down to this zero ground, if you like, the ground or the zero rail here. Now we've also got a couple of little parts over here in blue. We've got a push button, the little tactile switch that I showed you earlier there. We've got a pull-up resistor, typically in the region of about 10 or 20k, something like that. It's not critical. And we've got a little capacitor at the bottom here, which goes basically across the switch, and that's typically in the value of 0.1 microfarad. So we're going to be using a switch later to send interrupt input pins, and it's important that we actually keep the signal clean. I'll show you why later. But anyway, that's the circuit. +5 up here, that's our supply rail. Pull-up resistor, smoothing capacitor or filter capacitor, if you like, across the button switch, and a couple of LEDs. That's the whole circuit, and that's basically what we've got here on the bench. Okay, so that's what we've got. We've got the Arduino, some jumper wires, a couple of LEDs, pull-up resistor here, little capacitor in there, 0.01 microfarad to stop debounce, contact bounce. A bit more about that later. The push button switch, which we're going to use to send a signal to the interrupt. And that's all of the hardware. So now let's jump into the IDE, the Integrated Development Environment, and let's go and have a look at the Arduino source code we're going to put into the chip. Okay, so here we are in the IDE, the Integrated Development Environment as it's called, which is basically a piece of software that's been installed on the PC. Using this software we can write our own software to create programs and compile them and send them to the Arduino target board. So that's basically what we want to do, and we end up with a screen like this where we can write code like this. This is actually code in C language. Both C and C++ languages are both used quite a lot for programming microcontrollers. It's quite popular. So you'll see a lot of C language when you come to do programming. The Arduino IDE that we're using right now is basically a text editor. You know, we can just type in text in here. There's nothing too special going on here. It's all very simple. The only difference is that we have some buttons up here which allows us to do a compilation, which takes our code, our C language, and then converts it into hex files, into a .hex file, and then sends that to the target in what would be machine code instructions that the microcontroller can then read directly. You've got to remember that the microcontroller, or any processor for that matter, does not understand plain English like things that we've typed in here. This is really for our benefit, so we can understand what we're doing in C language. Hopefully. The processor simply doesn't understand that, so it has to go through what they call a compilation, or compiling the code into something that the processor or the microcontroller can read and understand, and that's referred to as machine code, normally as packaged up in a .hex file or in a hex file. That's raw machine code for the processor, if you like, that it can understand. So we're dealing with the text C language in raw text, if you like, in humanly readable text form here, and this is typically the sort of lines that we come across. I'll start with this very first line in the program. You'll notice that the line starts with a double slash right at the beginning here. That double slash tells the compiler, ignore everything after the slashes. This is just a comment or a remark, and that's purely for our benefit as a programmer. It's got nothing to do with the software. I could write anything I like in there, any old gibberish. It wouldn't make any difference at all. That's purely just for our benefit. So when we look at the source code, which is what we're doing here, this is all source code. When we look at this, we know basically this line of code is something to do with declare variables that will not change. Okay, and I've just written that in, and basically it just says that sort of this next line, if you like, or chunk of code, that's what it means. So whenever you actually see, here's another one, anything with double slashes at the beginning of the line, it's just a comment or remark, and the compiler completely ignores everything after that, purely for our benefit. Okay, with that said, let's keep going. Now the next thing is the actual line here, and you'll notice we've got some things going on here. It says const int ledPinFlash equals 13 with a semicolon on the end. So what does that mean? Okay, well, if you break it down, first of all, an int is a variable type. In other words, it's a storage location of a particular size. Now an int actually stands for integer, and an integer value doesn't have any decimal point, doesn't have any fractional sort of information. It's just whole numbers, integers. It can actually go plus and minus over a certain amount from 0. It can include 0 as well. So you can have values from, you know, for instance, minus 100 or 0 or plus 100, anything like that. They would all go in quite happily into a variable of type int. You have other things. You have things called long and byte and that sort of thing, and they're all the same but just in different. The only difference is the size of the variable, the range of the numbers that it can handle. Okay, and there's a reason, because you know we don't always want to use big numbers all the time if we're only putting very small numbers in, because it uses up a lot of memory, and especially with microcontrollers you don't always want to do that. Okay, it's the best idea to choose the correct size, and that saves RAM, if you like, or ROM, programming space. So here we're using an int that gives us quite large numbers. We only need to use the number 13 here, so it's pretty small. So that's what the int is. That's our storage variable, if you like. The size of the storage variable that we're going to allocate or declare, as we say. Const, that means constant, and it means that once you've put this value into here, it won't change. It can't be altered. It's fixed. Actually, what's really going on, you know, I said this was a memory sort of location or set of locations, a variable in memory. Well, const normally, it's not always true, but normally it instructs the compiler to put the value into ROM. In other words, it's not into a variable RAM location anymore, because it knows that we're not actually going to change it. In a normal situation, in most compilers, as I say, it's not always like this, but most of the time it will put this value into a ROM location in the microcontroller and not into a RAM location, because generally you tend to have more ROM space than you do RAM space, and compilers tend to know this, and so it's better to put them in the ROM location, because we don't need to change it. It's a constant. This bit here, ledPinFlash, is our variable label, our variable name. Now we've just called it ledPinFlash. It could be called anything you like. It's purely a human readable label, or a tag if you like, for the variable in the ROM that we're going to use. We're going to actually allocate the number 13. We're going to put 13 into that ROM location, okay, once it's compiled. So we're going to put 13 into ledPinFlash, which is a ROM location, and the semicolon at the end just means it's an end of instruction, end of line, or end of, you know, this particular job, this particular task that we're trying to carry out. And as I said, that's another comment, so you can forget about that. It basically is just telling us the number of the LED pin for flashing. Well, that's correct, because on the Arduino board, if you look at the circuit diagram again, pin 13 is our flash LED connection. That's the pin from the Arduino board connected to the LED. So we're basically saying whenever we use this in the program later, ledPinFlash, we're really just using the pin number 13. That's really all that line's doing. It saves putting 13 in the code all the time, and you might not always remember off the top of your head what 13 means, especially if you've got lots of pins and stuff. Could get really complicated. So we'll make it more humanly readable by saying ledPinFlash instead of 13 all the time. Next line. So here we have another comment. Declare variables that will change. Very much like the line above, except this time we've got of type int without the const. Now what that means, without the constant. So what that means is now it's going to go into RAM. Okay, This can be changed and it can be altered. It can be erased, it can be changed, you can do anything you like with it, because it's going to be loaded into RAM, because it doesn't have that const word which puts it into ROM. This is our own label again. We've called it ledState, and this time we're going to put 0 into it, which is simply going to put a numerical value of 0 into ledState. And this is a declaration that gets the value started, if you like. This is how we begin. We're just setting it to 0. And the comment here tells us what this line is: variable for setting the ledState status. So we're going to be using this later on to keep track of whether the LED is on or whether the LED is off. Next line, initialization. Yes, well, initialization pretty much does what it says. Let's get started. We need to allocate some pins and get things up and running. Anything we need to do to start the program before we actually start the main body of the program, we do it here. Now this is an interesting thing here. This is what we call a function. You notice it's got a couple of little curly brackets on the end of it there, and it has the word void in front of it, which you don't have to worry about right now. Whenever you see something like that, this is what we call a function. And all of the code between these curly brackets, these braces, okay, which I've highlighted there, including the braces, everything in between those curly brackets is the actual code, or the source code, which is part of this function. So when you see a function like that with the brackets on the end of it, then that's, if you like, a label for the function code within, and this is all the code that's inside of this function. Now, setup is not a standard C language instruction or command. It's important to realize that. This is a little bit higher level, what we call higher level. It gets a bit more sort of one word does a few things. There's more going on under the hood, if you like, or under the bonnet, if you're in the UK, than meets the eye. So it just says the word setup, but there's a little bit of code behind that that we don't see. And as I said, it's not standard C language, but the Arduino IDE compiler understands this and knows what to do with this function called setup. I hope that makes sense. Just remember that it's not standard C. If you try to take this program and you put it into a different compiler, you might get errors and it might say doesn't understand what setup means. You would have to then write your own function called setup and do that. This is really making the IDE simple to use. It's great for beginners. If you're just getting literally right into C just now and you've never done anything like this before, this is a wonderful way of just to getting things up and running and get some results fast on a board. So setup is actually, just remember there's a little bit of code behind that. It's not that much actually, it's not difficult, but they've made it that one step easier. Okay, so setup, and it automatically runs when the program starts. First thing we do really is get the thing set up. So here's a comment line. What does this say? Initialize the LED pin as an output. Right, now one thing to remember with I/O pins on a microcontroller is that they can be set to either an input or an output. You have a choice, unlike, you know, some I/O systems where the pins can only be an input or pins can only be an output depending on the hardware that you're using. Pins on microcontrollers are always bidirectional. They're not bidirectional, but let's say they can be allocated for either as an input or as an output. They can't do both at the same time. This pin mode function here, again, this is an internal higher level instruction or function within the Arduino IDE. Again, this isn't standard C language, okay? So there's a little bit of code behind that, and we won't go into that right now. Let's just assume, okay, that's what we want to do, and it's going to do the job for us easier than what it would be if we typed it out in full hand. Pin mode is basically going to set the mode of the pin that we want to set. So it's going to set this one, ledPinFlash. Now if you remember earlier on, I'll just scroll back up here, we actually set as a constant ledPinFlash as pin 13. So all we've really done is put number 13 in there. Think of it that way. Okay, but we didn't have to write 13. You know, what does 13 mean? Absolutely no idea. So ledPinFlash, oh well, that sort of makes sense. You know, it's the LED, the pin that we want to flash. So there you go. And we want to set it to a mode of output. So that pin is going to be set as an output, which is what we want, because looking at the circuit diagram, it's going to connect to an LED, and we're going to turn the LED on and off. So we need this pin set to an output, not an input. An input would be used for something like a push button or a switch, that kind of thing, where you're reading the logic state in. We're actually putting the logic state out to an LED. Right, so that basically sets the output mode of the LED pin number 13. And that's all of our setup procedure. That's all it is. It's a very simple program, this. Just got one line. Okay, now for the main body of the program. Now what we have with the Arduino IDE, they've supplied us with this function called loop, and all loop does is pretty much like main. It's the first thing that happens. It goes in and basically runs all of the code again between these curly braces, between these curly brackets. This is our main code, and that's why the remark at the top here says main loop, if you like. Could say main code really. But the difference is that this will keep going round and round and round. So once it's actually gone through all of this code and got to the bottom, we're going to loop and we're going to start again. And that's because the Arduino IDE has given, compiler even, has actually given us this function called loop, which does exactly that. It just goes round in a continuous cycle and will not stop until you turn the power off or press reset. What are we doing within this loop code? Well, let's have a look at a comment. Toggle the LED on and off for every loop. So that's pretty much the whole purpose of the entire loop. Now we've got this line here. We'll have a statement here called if, and if is basically a decision that we want to make. It can either be true or it can be false. So we either have a true result of an if or a false result for an if. Everything within these brackets here is, if you like, the question that we are asking. Okay, think of it that way. And what we're saying is, if, or if you like, is, question mark, is LED state equal to false? Now if you remember at the top here, we actually set LED state to a 0, which is, well, take it from me, that's the equivalent of false. Okay, if LED state is false, well yes it is, because it's 0, okay, then do some other stuff and it'll actually execute the code between these two curly brackets. So it'll do this digitalWrite function here. Now just before I tell you about this, I just want to mention about this double equals here. And the double equals is basically very different to the single equals that we used up here. Do you remember we used a single equals sign here? Well, a single equals sign is an allocation, if you like. We've put 0, we've copied it, the value of 0, and put it into the LED state variable. Okay, that's an allocation. We've put 0 into it. Okay, so we've set it. Think of it that way. Whereas here, we're asking a question. We're doing a comparison between two variables or between two values. You know, we're saying, is LED state equal to false? In other words, is the LED state off? Think of it that way. It's the same thing. But it's important to know the difference between a single allocated, if you like, a copy or a move of a variable, as opposed to a double equals, which means do a comparison. We're asking a question. Okay, what's the logical difference between the two? So we're saying, is the LED off? You could put a question mark on the end, but you know that's not C. But you know, for the purposes of explaining what this means, yeah, you could imagine it's got a question mark on the end. Right, so, and if it is off, do all this stuff between these two curly brackets here. Again, this is everything that the if will execute if it's true. If that statement is true, okay, then do all the code between these two curly brackets. Okay, well there's a comment. What does that say? Turn LED on. So that's what we want to do. Now we've got another function here called digitalWrite, and again we've been given a convenience function, if you want to call it that, within the Arduino IDE compiler to give us the ability to turn pins on and off very easily. There's a little bit of code behind that, just like the other things, just like pin mode and what have you. All it's really doing is allowing the pin to be either turned high or to be turned low. So it's made our life a little bit easier. It's just a function built in to the compiler, and the IDE is allowing us to highlight that. We can see it here in sort of orange color. It saves us having to write out a few lines of code to do the same job. Again, it's actually not that difficult to do it longhand, but why do it if we've got a shorthand version and it's all fast and easy to understand? digitalWrite. Okay, so we're going to take the value ledPinFlash, and if you remember that's actually 13, ledPinFlash. Okay, it's a const, so it doesn't change. So we're going to take pin 13 and we're going to make it high. So making it high, well, you probably guessed it, that will turn the LED to a high state. It'll turn it on. It'll turn the pin 13 will then go high or positive, and that puts voltage to the LED at that point. So that will turn the LED on. With the if statement, there's also this else statement. Now an else, if and else work together. So if that's true, then do that. If it's not true, Okay, in other words, if this line failed for some reason, if it wasn't true, else, okay, we do this line instead. So you either do this line if it's true, or you do this line if it's not true, in this particular case. The else is like, or else you could say, do something else, right? Do something else. So now we're going to use digitalWrite again, just like above. We're going to set a pin on the Arduino chip, output pin. We're going to set it ledPinFlash, again, that's our pin 13 if you like, to the LED, and this time we're going to set it low. So it's just the same as the line above. That turned the LED on. This line turns the LED off. We're going to set it low. And then at the end of all this, outside of the if statements, we have this little bit of code on the bottom here. Now ledState, as I said earlier, we're going to keep track of what the LED is actually doing, whether it's on, whether it's off, and that's what this is doing. So ledState equals, and that's a single equals, so we're going to move this in. Okay, it's not a comparison there anymore, it's an allocation. We're going to actually copy the value of this and put it into there, and we're taking ledState by itself, but now we've got this little explanation mark, this little pling sign here, and what that means is not. It means the inversion of. And if you remember our logic gates video, you know, when we're talking about inverters, that's kind of, this is the software equivalent of an inverter. So if ledState is on or true, then it means make it false. So it's the inversion of whatever it was. And of course we're copying it back into itself again. So all this line does really is invert itself. So if ledState was a 0 or false, then make it a 1 or true, make it high. They're all kind of the same thing really. We are actually taking an off LED and putting it on, or we're taking an on LED and putting it off. It's also referred to as a toggle function. Okay, it's also referred to as a toggle function. In other words, flip it from one state to the other, whatever state it's in, invert it, and then keep doing that sort of thing. Right, so that's keeping track of the LED state. That's done. Okay, last line of the code is this here, delay 100. Okay, with a little semicolon on the end, that's the end of the command, and we've got a double slash, so this is a comment again, and what we're saying here is we're going to delay for 1000 milliseconds. 1000 milliseconds equals 1 second. Alright, simple as that. So this delay function again is a convenience function built into the Arduino IDE to make our life a little bit easier. It means we can directly input the value here into as milliseconds, and what this will do is pretty much what it says it'll do. It will delay, or in other words it'll wait until 100 milliseconds has expired. And what I'll do is actually I'm going to increase that to 1000. Right, that's what it should have been. That's now 1000 milliseconds delay. In other words, wait for 1 second. That's exactly what that line does. It doesn't do anything else. We're not going any further. The lines of the code within the program are halted. We're not going to proceed and do any more instructions. We're just going to be waiting for 1 second to elapse. Once it's elapsed, then the code can all start again in the main loop. So in other words, think of it this way, all this code happens very, very quickly, whoosh, straight through, very fast, maximum clock speed, and then you get to this bit, and then the computer, the microcontroller, will effectively stop and wait and not proceed any further until 1 second has elapsed. Once 1 second has elapsed, then we go around and we do the whole thing again, round and round and round and round. And what that's going to do is turn the LED off. It'll toggle the LED state every 1 second. Okay, and that is basically all of the source code for this particular project, which we're now going to compile by pressing this little button up here. I know it says verify. It's actually the start of the compiler, and this will turn the source code into target code or machine code as a hex file, and then we'll press this button up here which says upload, and this will actually send it to the target through the USB cable. If I compile that first, yeah, it's actually compiling the sketch, and we've got some information down the bottom here which we can have a look at. That's done, by the way. That was very quick. It took about 1 second or so. It says sketch uses 912 bytes. That's 2% of program storage space. Maximum is 30,720 bytes. So out of 30,720 bytes available of ROM program area, if you like, in the chip, we've only used 912, which is only 2%. So you can you can see that we've only used a fraction of the available memory that we could have done, which means that in turn it means we can have much more complicated programs running and it would still fit on the chip. So this is a really simple program just to get us started here, and it's compiled without errors, so it's ready. So what we can do now is I can click this button up here, and this is the upload button, and this will actually it actually compiles it as well. It's a two-step process really, so but it doesn't matter. It's going to compile it again, and then it's going to send it to the target. Now if you look at the Arduino board, it's got some LEDs on, and I'm going to click the upload button now, and this will send the code through the USB cable. So it's 3, 2, 1, here we go, and you might see some LEDs flashing on and off a little bit there perhaps. Right, that's done. And what's happened now is it's actually sent the code and programmed the Arduino board straight into the AT Mega chip, and it's now running the program. And what you can see is the LED flashing on and off at 1 second cycles, which is exactly what we wanted. So there's the LED there. I'm not using the second LED just yet, we'll do that in a moment. So all we wanted to do was get that LED to flash on and off at 1 second intervals, and that's exactly what we've achieved. Alright, so that's the first example complete. Okay, well that brings us to the end of this programming video. It's a basic introduction, and I hope you've got something from it. You know, you've seen the software, our source code if you like, writing a little bit of C language, you know, with some extra functions in there from the Arduino IDE, things that are not in standard C language. And we've looked at the actual IDE itself, you know, as a text editor really, and we've done a verify, which also compiles the program into machine code, and then we've uploaded it to the target device, and we've actually had a look at it operating with LEDs and a switch. Yeah, not a bad start. If you're able to grasp what we've done here, then you're well on your way for programming. Okay, well I hope you've enjoyed this little video, this basic introduction to microcontroller programming with the Arduino. Well, thanks very much for watching, and I hope you've got something from all of this. And again, thank you, and here's to the next time.